Now, sometimes you can use shell method and sometimes you can use the disk method. I want to show you a direct comparison of them at the moment. For disk method, your representative rectangle is always perpendicular to your axis of revolution. So in this case right here, I have horizontal rectangles and I have delta y. And you see this representative rectangle is perpendicular to the axis of rotation. While here I have vertical rectangles and they're perpendicular to this axis of rotation. The volume formula for disk is pi, the integral from a to b, of the outer radius squared minus the inner radius squared. Remember, this is the solid disk here, and then you're subtracting off the volume of the whole. Well, the shell method is just a little bit different. Let me get the page here. For shell, the representative rectangle is always parallel. So my representative rectangle in this case is parallel to my axis of rotation. And the volume of each incremental shell is 2 pi ph times delta x or delta y, depending upon if you're rotating, whether your representative rectangle has delta x or delta y. Now remember, p is always the distance from the axis of rotation to the center of your representative rectangle, and h is the height of your rectangle. So h is usually f minus g if you have two functions. Now, you remember we did this problem right here using the disk method, and I needed two integrants to do that. And it wasn't hard, but it was a little messy. Suppose I try to do it now using the shell method. All right. In this case, I do my sketch, I draw in my representative rectangle, and I realize I have delta x. So I know my limits of integration are going to be from 0 to 1. Now, I need to identify what p is. P is the distance from the axis of rotation to the center of my representative rectangle, and the beauty of the shell method is it's usually just x, unless you're rotating about another line, and we'll do those in a bit. Now, what's the height of the rectangle? In this case, the height of the rectangle is top minus bottom. So this function right here is x squared plus 1, so this is the top of it, and the bottom is 0. I'm just doing that to show you that it doesn't always have to be just the function itself. So my incremental volume is going to be 2 pi times p of x, h of x, times delta x. So the volume itself is going to be the integral from 0 to 1, 2 pi of x times x squared plus 1 dx. All right, so this is 2 pi, the integral from 0 to 1 of x cubed plus x dx. Now this is a very straightforward integral. X to the 4th over 4 plus x squared over 2, evaluated at 0 and 1. So this is 2 pi times 1/4 times 1 to the 4th minus 0 to the 4th plus 1/2, 1 squared minus 0 squared, and I get 3 pi over 2, which, by the way, is exactly what I got using the shell method. Using the disk method. So you can use the two methods to check yourself.